Okay, for the next page. Sample problem 3.4. And a rectangular plate is supported by brackets at A and B and Y and C, D. And knowing that the tension in the Y is 200 Newton, determine the moment about A of the forces exerted by the Y on point C. Now, this is the wire CD is this one, okay? This one. And this one we know that the tension is 200 Newton. So, and determine, and so the question looks like this. And now determine the moment about A. A is this point, okay? Of the force exerted by the wire on point C, which is the force exerted by the wire is this one on point C, which is this one. Okay? And so this is TCD here. And we have, so where's, sorry, I think I should use another one. So TCD is the force we are talking about. And we have moment about A. So where is the moment arm? From where to where? The moment about A, the point we are talking about is moment about A. A is here. Where is the force acting on? The force is acting on point C. So where is the moment arm? Moment arm is AC or RCA, okay? AC or RCA. It's okay. So we need to determine this, right? So what do we know here? And we don't know because MA is equal to RCA cross TCD. And TCD is central of the Y. So we know the magnitude of TCD, right? We know the magnitude of TCD, but we don't know the direction of TCD. Direction is unknown. Okay. Of course, we can calculate this. We can get this by calculations, but at the moment now we do not know TCD. And do we know RCA? Also, it is unknown. Okay. What we only know is 200 Newton here. It's okay. We only know the magnitude of TCD, and we don't know the direction of TCD. We don't know the direction of RCA. So we only know the tension. So now we do this one by one. So we begin with RCA. Here we have moment arm. So moment arm is RC with respect to A is equal to RC minus RA. So I think because the coordinates of A, C, and D are known, so we have this one is equal to 300 I plus 0J plus 80 K millimeter. Okay. So we have. So now we have this one. We have got this. This is now CA. And for TCD, we know the magnitude of TCD, but we don't know the dimension of TCD. So how do we calculate PCD, the dimension of PCD? So we have we use the technique on notes, page 16 or example on page 17. Notes on page 16, example on page 17. So because we know the force goes through the line CD, and we can write this down, and we can first determine the unit vector is the direction of CD, which is equal to minus 6.6 I plus 0.48 J minus 0.64 K. Okay. So if you are familiar, if you forget how to do this, go back to page 16 and page 17 for the SOP. Okay, if you forget how to do this, go back to the notes, or if you don't know what I'm writing here, also go back to the notes. So if we know, so what is lambda here? So we use lambda for what kind of vector? Unit vector, very good. So we use lambda for unit vector, so the magnitude is equal to 1. Okay. Therefore, and for T, so T is equal to 200 newtons time for and I write it simplified like this one, which is equal to minus 120 newton plus 96 J minus 128 K newton. The thing you need to practice is how do we get this lambda CD. Go home and you do your homework. Remember how to get this one. After you get this one, then it's easy. So the last thing we calculate here is moment about A. So I'm so thank you. So I'll type it here. So remember the first row is IJK. So what do we fill in the second row? Second row. R or F? R, okay, very good. And the last row is F. And for here, remember I wrote as millimeter here. So if your final answer is the final, and this one is in Newton. So remember that you need to make the right units here. Okay. Take your time to mark them. Now, Yeah. Oh, you are, yes, thank you. Yeah, right here. Nice. Yep, thank you. So it's okay. Remember the first row is IJK and second row is R, the third row is F. Now, if you are fine that before we finish the lecture today, let's go to the next page. A single force P acts as C in a direction perpendicular to handle PC of the crankshaft. Crank is this one. And knowing that M is equal to 20 Newton meter, My is equal to this one, M is equal to this one, determine the magnitude of P and values of phi and theta. Now, here we have M. I think so. It does not stay very clearly, but it says MO respect to O is equal to MXI plus MIJ plus MZK. Okay, and then of course we have the force P here, and this one is point C, and this one is the moment arm is RC with respect to O. So what are the unknowns in this problem? The unknowns in this problem are theta and phi. Theta is this one. Let me write it clear. This one is theta and this one is phi. Okay. This figure is quite small, so let's look at the problem from this side and we draw the figure again. Okay. Let's look from the right and let's. How should I write it? So let's have our eyes here and okay. We look at from this direction. So we draw it here. So this shaft is along the x direction. So it is here. A and O are here, and BC and BC and AO are parallel. So BC is here. In this problem, we have the angle theta here, and we have the force P here, and this angle is phi. Is that clear? If we look at the problem, if we look at this thing, this crank from the right, we have this. Okay.我这个是引镜啊，看得出来吗？ So, and this 200 millimeter is this one. So remember the unknowns are P, phi, and theta. Now, yeah, take your time to fill in the graph. Of course, MO is equal to RCO cross P. So R is equal to from O to point C is what? And this is so we let's see in the x direction. So it is 150 plus 100 millimeters. So it is 250 millimeter I plus. So in y direction, it is in direct y direction is 200 millimeter times sine theta. 200 millimeter sine theta j. And in k direction, it is plus 200 millimeter cosine theta k. Okay, this is R. And for P, it is equal to value of P. Let me put it outside. I'm sorry, I don't need to. And because it has only for x components of P, it is 0, which is 0I. And remember, this P goes, because plus y is here, plus y is going up, and P is going down. So what should we do? P is negative, okay? P sine phi j plus P cosine phi k. Is that okay? And M is, of course, we know this is M, and but if we write it down in the, here that we have, so we stop it. Let me stop it. Let me give you some time to write it down, and before I go on. In this question, we know M is equal to this one, and of course it is a determinant of something. So for those who have finished writing, that think about what should we do here? What should we write down here? What should we write down here? In the first row, we have I, what else? J and K. And on second row, what should we write in? What should we write here? We only have R or F, so R or F. R, very good. So R is, let me write it in meter. So 0.25 and 0.2 sine theta and 0.2 cosine theta. And for the last row, so if we have the second row as R, the third row will be in, if this is R, so the third row will be F. So the third row will be 0 minus P sine phi P cosine phi. Okay. And please check this at home to see if from here we get these three equations. Should we write down anything in front of the in the examination? If you do this, should Do you need to write anything in front of the equations? This one comes from 20 is equal to this one, the product of this one minus the product of this one. So this one, the first equation, we get the first equation because we consider mx, okay? The second equation is my, and the third equation is mz. To protect ourselves, please write this down in examinations, okay? And then we get this. And from 2 and 3, we get, because cosine square phi plus sine square phi equals to 1, so we have this one. And then you put it back here, and from 1 that we get this one. And so 73.74 degrees plus 5 is equal to 53.13 degrees. If you hit your calculator, you will get this. If you use the, how should I do it? And sine minus 1, if you have a key like this, then you will get this one, 53.13 degrees. But this one will give you beta as minus 20.6 degrees. So it may be okay, maybe not. But remember that sine of 100 degrees minus beta is equal to sine beta. So there's another result like 136.87, and we have a beta is equal to 53.1 degrees. So actually we have two answers.